Welcome to Incredible Idaho. I'm Wayne Walker. Our show tonight takes a different approach to looking at our natural world. Most of our research projects we feature on Incredible Idaho are designed to find methods for preserving and perpetuating wildlife. But we can learn much more than this from our wild animals and native plant species. Think of all the wondrous processes plants and animals go through that we know very little about. For example, we know that certain echinoderms and crustaceans, like starfish and crabs, can regenerate limbs that have been severed. Now, if we could uncover their secret, imagine what this would mean to human amputees. We also know that slime on a fish has antibacterial properties that help protect it from infections. Could we someday learn how to use this in human medicines? And this recent newspaper article explains how scientists hope to create an artificial human retina by researching the way locusts perceive the world. Sometimes great discoveries, whether they be in medicine or other disciplines, begin quietly with someone who has a gift of curiosity and an open mind, and who thinks to ask the simple question, why?
I was reading about bears and learned that they don't produce urine when they go into the den for 4 or 5 months at a time. And it occurred to me that if they weren't able to produce urine to get rid of calcium that they should be getting rid of if they were getting osteoporosis, then maybe they aren't developing osteoporosis.
Tim Floyd is an orthopedic surgeon in Sun Valley. Some of his practice centers around skiers and their inevitable injuries. That seems to go with the territory. But a large portion of his patients are people who are stricken with a debilitating disease called osteoporosis.
Osteoporosis is a bone-wasting disorder. People get it when they're bedridden for long periods of time with certain disease states. People get it after they reach older age.
Tim's curiosity was triggered by the fact that hibernating bears are virtually immobile for 5 to 6 months of the year. Yet each spring, they rumble out of their dens a bit thinner, but otherwise fit and healthy. If humans were to remain immobile for the same length of time, there would be serious muscle atrophy and significant signs of osteoporosis, thin and weak bones.
In my mind, bears probably make a substance, well, in fact, I know that they make a substance, which prevents them from developing osteoporosis. And I thought if that could be applied to human beings, then we could eliminate a disease that costs tens, if not hundreds of billions of dollars a year, results in millions of fractures a year, morbidity, pain, suffering.
This is a microscopic section of bone from a bear that's been in the den for 4 months.
What we see is large cells called osteoclasts eating their way into the bone. You can see that the bone surface came along here just like this originally, but now there's a great big huge pit in the bone that's being eaten away by these osteoclasts, the ones that chew up the bone.
The bones of any human or animal who has been immobilized for several months, like this hibernating bear, would show similar pits. But this bear bone shows another process going on.
What we're seeing in bears that doesn't happen in any other animal that we know of on Earth is bone is being formed at the same time that bone is being chewed away up here. All of this is new bone being formed. So bears are producing a substance, a hormone, something that circulates in their blood that tells these cells to go ahead and make bone despite the fact that the skeleton knows that it's at rest and is not being used.
Tim's research caught the eye of scientists working in our nation's space program, NASA. One of the biggest biological impediments to long-term space travel is huge calcium losses and the corresponding development of osteoporosis in astronauts. Medical experiments were conducted on the Space Shuttle Columbia to analyze the alterations that take place in an environment with very little gravity. Findings suggest that the skeletal muscle system is greatly altered, even during a 9-day spaceflight. Could the mysterious hormone hidden in a hibernating bear's blood open the universe to space travel?
We're just barely scratching the surface. You know, I think that the more civilized we've become, the less observant we are of nature, and whether it's plants or animals or the stars or whatever. And I think that we get further and further away, and we think that the answers to our problems have got to come from a laboratory, or they've got to come from some institution that we've created. Whereas there's plenty of opportunities and plenty of answers out there in nature.
And how is Tim's research being received by the medical community?
They can check how much osteoporosis you have by a specific x-ray, and they can look at the density of it and in your bone. Yeah.
Michael Coughlin, an orthopedic surgeon at Boise's St. Alphonsus Medical Center, says anything we can do to stop the leaching of calcium in our middle-aged and older population is important.
Why such things as mammals that are hibernating don't lose calcium is fascinating. There must be some hormonal or chemical agent that has an effect on this, that protects this animal that's in hibernation. And therein lies some fascinating answers possibly to our osteoporosis crisis.
And it is a crisis. It's a painful disease that not only can cause extreme physical discomfort for patients, but it can also take an emotional and financial toll on the family.
Well, the estimates of our National American Academy of Orthopedic Surgeons is that as our baby boomer population ages in the next 20 to 30 years, problems of osteoporosis are going to be a health crisis for America. We're talking about millions of people that are going to be Medicare age, breaking hips because of weak bones or osteoporosis, and we're not going to have enough younger people to pay for the older people to be taken care of.
Perhaps someday scientists will find a cure for osteoporosis lurking in the veins of a slumbering bear. But that may not be the only medical marvel hidden in the animal's blood. Although bears have a relatively high fat diet and an extremely high cholesterol count, they don't seem to be developing heart disease. Tim attributes this to the fact that their blood has more of the HDL, or so-called good cholesterol, than the bad.
So somehow, in spite of the fact that they've got a high cholesterol, bears are able to have a high HDL cholesterol, and I think that is probably protective against them developing atherosclerosis. And this is just another area where I see an application of what we can learn from them to treating human disease.
And what about the fact that bears don't urinate during the 6-month period they're hibernating? Could research on this someday be applied to people who are dependent on dialysis? Is the answer to fighting kidney disease or curing diabetes linked to the mysterious processes and unique physiology of this secretive creature?
Each answer raises 10 more questions, and so I just see endless opportunities to learn from the bear and apply it to our own situation.
It's very icy. Feels like a little frog popsicle, actually.
Frogs and snakes and related amphibians and reptiles have fascinated mankind for centuries. They always seem to be one of the required ingredients when witches and sorcerers were brewing their secret concoctions. Now these days, instead of throwing the creatures into a big black pot to die, scientists are conducting research on how they live.
I don't know, maybe we could get him to dig here, I don't know.
Herpetologists, biologists who study amphibians and reptiles, have known for a long time that these animals deal with temperature extremes in unique ways. For example, the Great Basin spadefoot toad is specially adapted to live in arid sagebrush regions like those of southern Idaho. In times of drought, they burrow into the earth to escape the heat. There are also several types of frogs and turtles that are freeze tolerant.
A lot of animals just dig down a little bit, bury themselves in the wet dirt, and spend the winter frozen solid.
It's an amazing process. The animal's blood ceases to flow. Breathing stops and there's no detectable brain activity. But each spring, when the world around it begins to thaw, it comes back to life. Ken and Jan Story, researchers at Carleton University in Ottawa, Canada, are studying this phenomenon.
To take an animal, a vertebrate, a higher form of life with a brain, a heart, a liver, freeze it solid, and then watch it come back to life, it's tremendously interesting to us. What are the mechanisms? How does it do it? How is it controlled?
Part of the answer is a protein found in the blood of these animals that helps them to regulate the freezing process. The research team has also discovered that huge amounts of glucose build up in the internal organs. This works much like the antifreeze in your car's radiator. It prevents water inside the organ's cells from freezing. Then, as the frog or turtle begins to thaw, all the remarkable processes of life kick back in.
The limbs are the first to thaw with ice leaving the skin. The skin's now soft and supple, whereas before it was solid as a rock. The animal isn't injured at all. You can feel his heart begun to beat again, and he's begun to get active.
Imagine the medical applications to our organ donor programs if we could imitate this process. Right now, we have the capability to freeze human blood and sperm and preserve it for future use, but not human organs. Human hearts and livers must be transplanted within 12 hours to have any chance of success. Kidneys are viable for 24 hours. Now, if we could extend this period, it could bridge the distance between donor and recipient, buying time that could ensure a match. Perhaps someday organ banks could be as common as blood banks.
Does the frog and the turtle, in the way they freeze, in the protectants they put out, in the way they can survive ice, tell us something about how we can take a human organ, freeze it solid, keep it for some period of time, thaw it, and have it survive as well?
Scientists are also studying snakes in order to understand more about the human digestive system.
She's constricting the rat. Now what she's going to have to do is find the head, because they swallow the head first.
This is flippers, a white-lipped python. Pythons kill their prey by coiling around the animal, suffocating it, and causing heart failure. The snake swallows its food very slowly, and digestion will take from 3 or 4 days to a week. This exaggerated process makes for a perfect depiction of how our own digestive systems work. Flippers belongs to herpetologist Frank Lundberg. She's one of a collection of reptiles like this lizard named Spot, studied and cared for by Frank. Like the snake, Spot also swallows its prey whole, but it's a much quicker process.
There's dinner. The rat got down in the stomach, and as the rat got into the stomach, it triggered the production of enzymes and hydrochloric acid increase, and of course there was a little more oxygen. In fact, in a snake, a lot more oxygen required for those chemicals to process the food. Now, exactly the same chemicals are present in our bodies, but what the snake can teach us, because it takes longer to digest, does it over a longer period of time, and it's a slower process, by observing what happens inside the snake's body through x-rays and through analyzing chemical substances, we can get some clues as to how our own digestive systems work.
Some snakes, like these Great Basin rattlesnakes, kill their prey by injecting them with a venom, a modified form of saliva. This begins the digestive process inside the prey even before the snake swallows it. The venom acts as a toxin to break down the animal's blood and nervous system.
And German scientists have discovered recently that we can use some of the venom from the Malayan pit viper to create a drug that can be used to help stroke victims, because it's an anticoagulant. It does break down some properties of the blood. So we're discovering through science that what nature and what animals have had all along has always been there to help us, and perhaps it's an untapped resource that even what some we consider to be the lowly snake can actually be of great help to us.
Since the beginning of time, mankind has been experimenting with plants for medicinal purposes. Now, this medical library can only contain a fraction of the knowledge accumulated over the centuries. Digitalis, morphine, quinine, even aspirin. All of these common medicines are derived from plants. In fact, nearly 40% of medical prescriptions dispensed each year in our country are based on substances acquired from nature.
Well, the pharmaceutical industry does all kinds of things to come up with new medicines. They search the rainforest looking for bacteria and fungi. We look for the plant kingdom. There are things out in nature that are cures before us that we just have to figure out.
Linda McMahon, director of the Barry Botanic Garden in Portland, Oregon, calls plants little chemical warfare factories.
Plants make chemicals to protect themselves from bacteria, from viruses. They make chemicals to produce very bright colors that might be warning coloration. So there's just all kinds of chemicals that plants make for their own benefit. And the great thing for us is that we can be sort of the secondary beneficiary of some of these chemicals because they may be useful to us as well.
Scientists estimate that there are more than 250,000 different plant species on our Earth. So how does one know where to begin?
We can go first and look at the plants that were useful to native peoples, either here, in the Amazon basin, and other parts of the world, and see what chemicals those plants might have that could be useful. And sometimes it's very different from the use that the native peoples used it for.
One such plant is the rosy periwinkle, a species native to the island of Madagascar. Medicine derived from this plant has proven effective in saving the lives of children stricken with leukemia, like Jackie Buckley and 9-year-old Whitney Hare. Both of these children survived, but the native rosy periwinkle did not.
Today, 90% of all the forested area of Madagascar is destroyed. 100% of the native habitat of the rosy periwinkle is gone forever. Had that drug not been discovered, I'm certain my daughter and lots of other people who've had blood-related cancers would not be alive today.
What other undiscovered cures have been lost or may soon be squandered due to neglect, ignorance, or greed? Linda McMahon estimates that more than half of the rare and endangered plants in our country are related to plants of known medicinal use. And she, along with the staff of the Barry Botanic Garden, is taking steps to ensure that these plants don't disappear.
And what we do is we conserve seeds here in the seed bank as sort of a hedge against extinction. Both fire protection and protection for changes in humidity and temperature.
Inside a fireproof vault, packages of seeds line the shelves. Some are still drying out in this temperature and humidity-controlled environment. Others are in boxes, waiting to be counted and processed. And nearly 2 million seeds are stored in this freezer, representing over 250 rare and endangered species native to the Pacific Northwest.
The seeds are stored inside these metal foil packets, which are virtually impermeable to water. And at the temperature they're at, which is about the lowest setting for this freezer, they will be viable for 100, perhaps 200 or 300 years.
What will our Earth be like in 300 years?
Scientists are running a real race with time right now for a lot of different species in ecosystems all over the world. And a lot of the species that we get medicines from are actually endangered species.
Monica Bond with the National Wildlife Federation cites the Pacific yew as an example. Although not endangered, the tree was considered a waste species. But all that changed when it was discovered that the bark of the tree contained Taxol, one of the most promising drugs in the fight against ovarian and breast cancer.
It just goes to show that a lot of times there's incredible value for humans in a species that you wouldn't have thought of before, that was previously thought of as a trash tree. They would just sort of throw it on a slash pile and burn it. And this is something that saves women's lives.
Only 2% of the Earth's known plant species have been thoroughly examined for their chemical properties. What else is out there? And will we find it before it's lost forever? These are troubling questions to botanists like Linda McMahon.
Well, of course it concerns me that we're losing plant species. It concerns me for many reasons. One is that it's part of our heritage, that is nature and all the plants around us are part of our natural heritage, and we need to protect those in the same way that we protect our own cultural heritage, because they're part of us in many ways. But it concerns me also because plants are of value to us. As we lose plants around us, the potential for their providing something that's useful to us just gets less and less as we go along. The more we lose, the more potential we lose.
But I think for me it's something that really just comes from the heart, that I don't like to see these areas gone. I think that they're incredible. I think they're a gift from God.
The people featured in our show tonight all seem to share a passion for preserving our natural heritage. As we close, we'll leave you with some of their thoughts.
Well, I think there's a lot of reasons why we need wild animals and wildlife and wild places, but one very applicable, very concrete reason that they're good for people is that we can learn something from them. So I think there's a lot of applications to human beings that can be directly derived, and I think that's why it's important to protect them. That's why it's important to provide places where they can be protected.
I think it's important to be talking about the economics and the fact that human beings really benefit from protecting these ecosystems. But I think for me it's something that really just comes from the heart, that I don't like to see these areas gone. I think that they're incredible. I think they're a gift from God, and they have all sorts of different values. Not only medicinal value species or economic value species, but a spiritual value as well, and an ecological value, incredible ecological value. And all of those are intertwined. You can't separate them.